This is the brand new Jonker Sailplanes factory, 10,000 square meters and quite possibly the largest sailplane production site in the world. I got the full tour with CEO Uys Jonker. But a few years back, I actually got to fly one very special J3 in South Africa.
Hi Uys.
Stefan, welcome to South Africa, to our new facilities here, and thanks for the effort coming all the way out here.
It is really huge here. I just saw the old facility at the airfield, and this here looks completely different, like a dream facility.
Yes, it was never our dream to have a huge facility. Our dream was always to make dream gliders.
Yeah.
And slowly, as we were for 25 years on the airfield where you've been, we slowly expanded the facilities, and finally, with this organic grow, things wasn't in a nice flow and we couldn't obtain more property at the airfield, and at one stage we had to expand. We had no more space for the aircraft, and we would start looking around for facilities in town just to expand. And we even approached this facility here just to move our final spray areas and final assembly maybe here. And then the owner often said, why don't you take the whole facility? They're thinking of stopping their business, which was a furniture distribution business.
Okay,
and
so
that's where it started.
So that's not a new build here, it's something which already exists and you renovate a bit, or?
Almost in between.
Okay.
Most of the area was here, like I think 75% of the building was here. It was about 6,000 square meters of facilities, and we could not fit in the flow inside the existing buildings. So we had to expand the sections where we do the processes that needs temperature control and dust control, and to create the internal flow, but also a complete external flow for the final product.
Okay.
So therefore we had to expand by about 4,000 square meters. We had to expand the facilities. Now it's about 10. It looks a bit big, but I think it's okay.
Yeah, it is just huge. Let's start over there. Let's make a normal production of a glider, just to see all the different facilities.
Now let's go there.
And let's head over there.
Ah, please enter. I think we're not allowed to enter. Let's try.
Let's see what goodies we find here.
Oh, I think it's like a toy shop. You can find all parts that you would like for your glider.
For
you
avionics, it's great here.
Avionic parts, wires. I see there's gas struts. There's a whole bunch of things. If you look through this is mainly, I think, the off-the-shelf parts that we find here. But it's actually phenomenal how many parts goes into a glider. If you look, every single of this part has a specific application inside the aircraft. So these parts are now, which we see the foam parts that installed as the core material. So we have a section, and we'll see later in the distribution area, how the foams are machined specific to size to ensure repeatability on the product. You will see now a bit more of the parts that we construct ourselves, coming from the part manufacturing shop. So these are typically of the side panels that comes into the aircraft itself in the cockpit, which is more cosmetic related parts. This covers the metal parts produced from the metal shop. For example, this is a bell crank coming inside the wing, transferring the push rod actions into the final rod pushing down here. Well, all of these parts are pre-manufactured in our metal shop area, and then kitted like this with all the bolts connected to simplify installation at a later stage. These are the larger parts, and this is mainly to protect the pilot. So these are the shells, the double shell inside the cockpit, transferring the loads, especially in a crash. You can see it is quite a supply line as you move around here with all the pipes and tubes. Even these tubes are produced by our sister company, On-Track Technology, so they produce all the carbon tubes for us. Inside the supply shop, as you can see, bolts and nuts, hundred thousands of them, all the different type of bolts that we want to use.
Super important.
Part of the store supply is also, morning guys. Morning.
Stefan.
So also inside the supply is where we manufacture the instrument panels, complete panels. So the panels are produced as a complete unit here. All the instruments are installed, wiring done, and it is just plug and play into the cockpit. So once we came to the aircraft, there's very little wiring to be done, and it's just some plugs that needs to be plugged in. And in this area is where we do all the electronic work, the buck wipers, the instrument panels, and some electric parts where required. So this is the second store the second part of the store where you see the incoming inspection is done and then distributed into the facility. And this side is more the consumables of the factory, the cleaning materials, stuff that is normally not flying. Here you can see this is where we lay out all the looms running inside the factory. So we have these loom benches to ensure that all the breakouts of the leads are exactly at the correct space. And then when the loom is installed, we have a consistent installation of the loom, just to reduce also time and mistakes on the floor.
Yeah.
Pre-manufacturing looms is just one of the better ways to go.
How many days does it take to produce such a wiring loom?
That you have to tell. 2 days.
2 days, okay.
2 days of work for this loom. So now we will take you all the way to the supply stages. So here's our 2 composite shops, our CNC shop and our metal shop. So we start here in the metal shop side.
It's so huge.
Now we're entering our metal shop. So almost all metal parts that we produce, except for the highly specialized CNC parts, which is produced on the other side by our sister company, all the other parts are produced here. So the store supply is sitting on the section over there.
All the rods.
All the raw materials.
Yeah. Wow.
And one can imagine it's a huge number of pipes used throughout the aircraft. Most of these are 4130 steel, which is an aircraft high carbon steel, strong steel. And then you also have the aluminium rods and some stainless steel, some place where we can use stainless steel. If you come down here, we have some traditional hand milling machines, because there's a lot of operation. We just have to do accurate drilling or cleaning of some of the parts, which cannot be, which needs to be in a process completed coming off the CNC machines. So a number of these machines in operation.
You said you have more CNC machines at a different workshop or at the airfield, I think.
Yes, yeah, there we have a huge bank of CNC machines, lathe CNC machines as well as high-tech milling machines. Okay. So this is typically an example of a CNC machine down here. Morning, Christo. Which parts are you making this morning? This seems to be the rear canopy pin core, which looks like this is now halfway through the process. You see that part still needs to be machined in here. Okay, so it's busy with the setup of the part, and once the setup is completed, we'll push out hopefully a year's stock.
Yeah.
So normally when we start up the machine and we set it up, we produce for a whole year. So we only have to do the same program once a year.
Yeah.
Thanks, Christo.
Thank you.
A lot of hand work is also required in the metal shop. If you look in this section here, which is a bit more noisy, that's why we isolated it, where parts are produced using hand methods. Typically some of the parts are being reworked or reamed or assembled here with some of the specific bearings. I can see here's some assembly that's happening on a metal part that's externally produced by some of the other areas. Okay, so this is our welding shop.
Nice to meet you.
So our aircraft welding shop in this area where all metal parts are being welded, as this been welded this morning. So if you can have a look here, so these quite complex welding parts. I think this is some bell crank auto coupler at the wings that you might see. In further processes, we'll get the bearings in there.
Here you have the raw parts.
That we assemble in a jig. When everything is tacked together and welded as far as possible inside the jig.
And then you
move from the jig, and then you will basically do the bottom part.
Yeah, awesome.
So all this part of water jet cut, we'll show you now. A water jet cut machine is just around the corner here. We also have some good thunderstorm outside there.
Yeah, no flying weather today.
or very exciting flying. Okay, so here's a water jet cut in operation. So it's quite a bit noisy, but you see all the parts, the metal parts being manufactured by CNC. So wherever we can, we try to use accurate CNC machine operations because of repeatability and also cost savings.
Yeah.
Which brings us into the normal CNC shop. The normal CNC shop consists out of cutting raw material, but also machining parts for assembly. In this section, raw material is being cut. If you can see now, all of these material parts are being cut to the correct shape, and then it is packed for the layup sections to use the material already pre-cut into the correct shape. Now you saw previously all these foam sections and metal plates. These are all the stock of glass plates. You see all different sizes, which is required in different areas. If you look at this plate, it's quite a hefty, like a 10mm glass plate.
But you also do that in-house, or you buy these raw?
These are produced by our sister company at the airfield.
Okay.
And they use the infusion process because it's just bearing material.
Yeah.
So they use infusion process in delivering our glass plates for us. So we don't buy any glass plates in, with other words. And you can typically see this is typically a part that's machined out from a huge thick plate of glass which is a structural member which needs to be installed probably somewhere near the main bolts of the. If I look at it, it's strong part.
Yeah,
it must serve some function.
It's really heavy, yeah.
Yeah.
Cool. And that's done on this big machine here.
This is one of our CNC machines. We have two machines of this caliber, one a 5-axis also at the airfield, but at this moment it's busy machining JS4 wing molds, so it's not available for production.
Oh.
Yeah, so you can see now the machine has been set up with the plates, and then the different parts are machined from this raw materials. And then obviously you just have your standard machines where you sometimes just have to cut the parts loose.
Yeah.
But as you can see, they're cut in templates, and then there's a bit of hand machining required just to cut the parts loose. So this section is what we call of the composite shops, it's called the large composites. Large composites consist out of tailplanes, rudders, spar caps. So the slightly larger components that doesn't fit into the main line, but which we see as a part that's applied. So all the parts here first go into the shop, into the stores, and from the stores it's then kitted and distributed into the line.
These are wing spars probably, or?
Yeah, so if we look down this line, I have a suspicion these could be this could be JS3 molds if I look at this. And the spar caps has just been produced. Yesterday produced, already been cured. And you can see the number of layers are marked down here. You see, I think up to that point it's 64 layers of that tape. And 64 times 32 lines times 12,000. So it's a huge number of carbon fibers at these.
And it's all manual laying down and...
Yes, here is the process how we do the manual laying down. You can see down here we already have the JS4 spar caps being manufactured. So these are the first prototype spar caps of the JS4
cool.
in process. Typically here you see what the machine looks like with 32 rolls of carbon is going through a tree and then through a resin process. Okay, if we move over here to the large component, typically a rudder installed with an antenna here. And if you look on this side, we're producing a tailplane here, and I think we're different from the other manufacturers that we have the pyrostatics inside the tailplane. At this moment they're putting them in the bonding glue, which is a combination of cotton flocks and aerosol to the correct mixture for the bonding process. And once it's closed, it comes out of the mold and it looks like the tailplane just on the other side down there. This is the top skin, which will be bonded onto that thing in a few moments time. You can already see the cranes are ready to lift it up and do the closing process in a few minutes. The small composite area has its own curing oven. So here we have an internal curing oven. I don't want to open the door now, but if you look through the windows, you can maybe see some parts that we post cure independently before it goes to the big curing process. So we're curing parts before we install them in the aircraft, so that they already settle, and that the post curing process is to a more advanced stage before you do final post curing. The small composite shop also has its own spray booth, and inside here you will find most of the small composite being manufactured that you saw on the other side. But as you can see, we created sufficient space for the small composites to enable production of a very high standard and quality.
So much space, it's crazy.
Yeah, so that brings us now to the next stage. Okay, now we enter the line where the product is actually produced. So normally all the spare parts are coming and flow into kits into this area, and this line operates here.
I thought the other hangars were already big, but that's huge, really huge here.
We are a bit nervous because if the JS5 molds has not arrived here, they're still at the R&D site, and the JS4 molds coming in here, so this line will be fairly under pressure, so we'll have to have a place to store the molds as well.
Okay.
So maybe we start on this side. If you have a look in the molds here. So this is the assembly line of the molds. You can also see wings in an advanced stage of the skins being produced. So there will be spaces for each aircraft on a specific line where the construction is happening. Once the construction is completed, the mold will be cleaned and go into the spray booth area. So it starts in the spray booth area on this side, around here, and then it goes into the clean room. So maybe we just walk through it.
Yep.
So this is a spray booth. The spray room.
Whoa!
Please enter. So pardon the noise, the vacuum is on. So this is a JS3 inside the mold. The gel coat has been sprayed in the mold. It moves into this and then it moves into the wet layup room. So it rotates now and moves into the room. But as you can see, we have a huge spray room here, enabling a very, I would say, neat operation. Protecting the people from any overfumes. So then we enter obviously the wet layup area. So this is our clean room. As you can see, we try to keep it clean. The sprayed molds with the gel coat enters here, and then the wet layup process happens. You can see all the drawings of the different products
Wow, okay.
are on the wall here, and they produce obviously according to the plan. The raw materials down here. Now, quite interesting what you see happening here is we're currently building a DG1000T fuselage here at this moment, as we're also producing DG1000 fuselages with our combined company JSDG production. So here's a DG1000 fuselage in birth process. So once the lathe has been completed at the end of the day, it goes through these doors into the curing oven. So that's the overnight curing. It's a low temperature curing process just to excel the curing of the material so that the manufacturing can proceed the next day. So this is a huge oven. As you can see, the idea of the oven is that the molds are parked in here, but even if you do overnight curing and you join a mold, you can also have in process into the mold. So it serves the wet layup, but it also serves the assembly line for overnight curing processes. All right. Once it's cured inside the curing oven, it moves directly into the trimming area. Now this is your dirty area, so pardon the dust, but here you'll see it moves directly into this area, trying to keep the dust outside of the main factory. But this is where the assembly of the aircraft happens, where the fuselage and the wings are meeting for the first time, where the integration process happens. So these are the drilling jigs where the two wings are mated, and once they're mated, the flaps are being installed, and then it's mated with the fuselage. So this is what we call the dirty integration shop. But as you see, we try to keep it as neat as possible, but this is the most dirtiest part inside the factory.
Right, and you have these huge vacuum suction things.
Yeah, these things
just to get the dust away.
These things are designed. These things are designed to make life quite easy and clean the product. We are still used to it. In the previous factory, we had none of these fancy dust extraction units. But it really helps us to keep the dust control and to enhance the quality of the working environment.
And of course, it's also better for the employees to.
Much better for the employees. But what we believe is that we can produce a higher quality product if the housekeeping is the maximum level and that the facilities support the processes. And now for the first time we have really processes or facilities that creates the process in the environment where it needs exactly what's required. Coming out of the integration shop is the paint shop, where it should be a bit cleaner. Just take into account this is still work in progress, so we're busy commissioning the paint shop. So our challenge on the previous site was that we didn't have enough paint shop spaces and to prepare and sand, and this is the first time where we actually designed the process, what's required. So the first step, if you can have a look here, is the dry sanding area where most of the dust is created. So you see inside the paint shop there's absolutely no dust. We try to keep the dust free, and if you look inside here, I'm not sure if you can enter here. Okay. So this is the dust area. So dry sanding is happening here in the preparation for the paint shop. And you can see good lighting and temperature control here, and most of the processes happening here that creates dirt is made outside of the paint shop.
And how long does it take to make all the painting from where the surface finish here for one glider?
We normally allow aircraft to be 4 weeks inside the paint shop, because if you take it a bit slower, then the process of curing is more advanced. So if you rush the process, what we have seen, you have more shrinkages and surface distortion at later stages. So just to slow down the process slightly is more beneficial.
Okay, but you have space here for more than one aircraft.
Luckily, yes. Yeah.
It just looks huge, but these are not all paint booths, or?
No, this is a curing oven.
Oh, okay.
So after paint shop, we can go into the curing oven. As you can see, it's not prepared as yet.
Yeah.
But this is the intention of this is to cure the product after it's been painted.
Okay, how high temperature is it?
Only 45 degrees.
Only
So it's
45.
low temperature, so you don't want to do any post-getting again. And then we have the two spray booths. So one spray booth is dedicated for the white top coat and the other one for all the colors. But it's also redundancy, so whenever we have an issue with a one booth for maintenance purposes, we have a redundant system without affecting production. Yeah, so obviously over the years we were never satisfied that we have reached the stages of the paint quality what we aim for. And introducing Werner into the process and with the new facilities now, I believe that the products coming out is really something to be proud of. I think we did well. So Werner, so thanks for your work, and tell us what were the secrets?
Well, experience was a secret. Years of experience, production changes, procedure changes, just looking at more modern procedures, more modern products. As you can see, we've obviously invested in ourselves. We've really, I think, prioritized paint, and in a factory layout like this, you can see we've prioritized paint. So it's very important to us to have like very low customer complaint snags in paint now. So we really address and speak to the customers and ask them what they want, and really like we at the moment trying to get through to the customers and show them that we've changed our processes, and we're really proud of what we're doing at the moment. So that's very important to us. So the customers, obviously in past we had some here and there few little issues as anyone has, but we are not ashamed to admit it, and we are very proud that we could deal with it in a good way and get the quality where it should be. And I believe we're probably the best in the world now. So yes.
Or we at least work towards it.
It looks insane. I didn't see that on any other sailplane manufacturer to have that line. I think we need to look there at ultralight or plain painting booth. I don't know.
I've worked in a few areas, and I must say this is the first area that looks like this where I've worked. I've never seen a spray booth like this, a spray shop like this.
Even our bathrooms inside the factory, we try to keep it the same level as our product. So if you look here, we try to keep a high level of industrial bathrooms, just because I think a bathroom almost defines your identity if you're serious about housekeeping or not.
You are not scared that the employees just sit there because it's so nice and watch on the phone?
At least they have an excuse. It's nice enough to do it. So the final assembly area after the rough area, which was dirty, is now happening here. So this is the more clean final assembly section, where we're just prepared before it goes into paint shop. And in this corner that you see down here is the dedicated DG1000 workshop. You can already see some preparation work is done here for the fin section with all the DG1000 tooling. So this is the small Brugsaal area, Brugsaal in South Africa. But as you see, the fuselage is still in construction at this moment, so it will be arriving here shortly. Some of the areas that's not been 100% completed is the canopy area. So this glass area will be the canopy area where you fit the canopies on, which needs a bit more temperature and dust control area. And this is why we call this a clean room, and should be in commission in a couple of months or so. We'll be ready with it. With some night offices on top that will make some factory offices. And now as we move through the factory, it becomes more clean. So this section is the final assembly section where the final touches happens, the installation of the instruments and the engine systems are happening. On this side, you will see the final wiring looms are being pulled in, the cockpit is being constructed, the final fitting of the tailplane and rudders are happening here. And then if you move out of this section, it's quite empty now. So you can see there's just one aircraft in production here. So the next one's coming from paint shop, will be entering production soon. And then we have a bit of a pile up in the engine installation section. So firstly we have the new Solo 2625IS, or silent engine, or we call it the stereo engine, which, as you saw before, it's absolutely phenomenal, addressing the vibration issues. The bay has been constructed here, prepared for the drop-in of the pylon. So you can see here all the preparation work has been completed here. The engine pilot is then constructed separately, and the drop-in installation into the fuselage. So it takes about a week for the final stages of the engine to be completed.
And did the engine run before already outside of the glider, or is it installed and will be on for the first time in the glider?
It is tested at Solo in the production line, so they run at least an hour on it, but they have to comply with the engine run-in protocol, which could be, I think, is about an hour on full power, which they test the engine to ensure before they dispatch it for installation. So we have Leonor here, one of our specialists installing the engine here. Now this is the final product. You can see all the wires and cables nicely, neatly hidden, and we try to make a fairly clean installation.
Let's have a closer look here to the cockpit. We see here all the smaller parts, also the optical carbon fiber parts on the side. Yeah, here, these sliding pockets, an invention of you.
My personal, but it's my only contribution to the design team. That is my level of engineering that I accepted.
Yeah. Great.
Yeah, if you look at some of the cosmetic parts, as you said, the interesting thing that we made different to this aircraft is the prop stop. So the propeller does not have sufficient friction in the system to stop by itself, so therefore the propeller brake is required. So if you pull that propeller brake, which is hydraulic brake, it stops the propeller at any position. Once it senses that it stopped, and you already put it, when you stop, you can just retract it. So if you retract it and the propeller is not in position, you see the prop brake coming out. So now you see the prop brake coming out, and it advances it to a small position downwards. Because of the speed of the propeller, it will slowly go over the compression phase, and it will continue until it hits a stop. Once it hits a stop, it will then proceed and do the full retraction.
Yeah.
All done automatically.
What does it cost extra if you want to have like such a nice paint scheme here on the front, or is it included?
No, there's all options for different paint settings depending where you select it. So every section has got a specific price on it. If I remember correctly, by having these complex paint schemes, about €3,500 extra. So it's quite a bit of extra money involved in it. But we try to break it down so that each design costs the exact hours that it's costing, which we charge built towards the customer. So you can actually build it up so that it's not always the full complex price. Yeah. And you can also see we try to match the upholstery with the colors of the aircraft. As you can see here inside, how nicely the upholstery matches the paint design. So these are the thinking area, where a lot of thinking happens simultaneously and all the time. So we have some garden offices here, so you can actually open the doors here and experience a bit of.
But it's quite smart
outside.
Because you see all the green, you see a bit of light and so on, but you can't see the cumulus if you're sitting in here.
What cumulus?
Yeah, I don't know. Maybe it's not the best country for glider flying, I don't know.
Used to be. So that ends our tour of this small production line here, and I hope it was interesting.
It's huge, it's super cool to see the complete process of a glider from start to finish, and the facility is amazing.
So I hope you can travel by glider and tell us if this is the ideal product for travel by glider.
Yeah, we'll see.
Thanks, Stefan.
Uys was also always playing cricket and rugby, and he didn't think much of me flying gliders with my dad, and eventually I think he's losing out on something, so we joined the going out to the airfield on the hot days and do some gliding. But in the end, we built this company, but in the end of the day, Jonker Sailplanes is Uys Jonker. Uys made this all happen, you know. Me and Bossy think out the new stuff, design the new gliders, it's all fun for us. Uys do the hard work, he makes this company. The heart, the soul of Jonker Sailplanes is Uys Jonker. I just want to thank my brother for taking my dream and making it his dream and running with it far further and wider than I ever thought or envisioned what would happen. I wanted to build one glider for me, and perhaps two gliders, one for me and one for Uys. And now we're building gliders for everybody, you know, and it's quite humbling when you fly in the world championships and you say, I'm chasing this guy, I can't catch him. He's flying a Jason like. Okay.